In today's class, we're going to talk about the Extensible Markup Language, XML, and semi-structured data. XML was really designed as an information interchange format that allows us to transfer and exchange data between different people. As we will see, you can also validate the data and its organization within the XML data format. There are two types of XML. There's what's called well-formed XML and valid XML. Well-formed is the simplest format of XML, and the requirements are much more relaxed. Basically, every document must have a root node. Every opened tag must be closed, and I'll explain what that means in a second. And there may be no overlapping tags in the XML. Valid XML format is well formed and it has additional specifications. In particular, it must be able to be validated against a definition. The XML file has to contain a pointer to that definition, and the definition is basically a contract that the XML file has to adhere to be valid. Let's start with well-formed XML and see what it looks like. You can consider XML as basically a tree-type data structure. We start with a root, and the root, of course, has some children. In this case, two nodes, node 1 and node 2. Each of those nodes has children as well. Node 1 has two children, nodes 3 and 4, and node 2 also has two children, node 5 and 6. Those nodes have children, and so on. In this tree structure, there's a hierarchy between the root node and node 1, and node 1 and node 3, node 1 and node 4. There's no interaction, no relationship between node 3 and node 2. And as part of well-formed XML, you can't have conflicting tags that overlap. Your XML file should begin with a declaration that it is indeed an XML file. The simplest declaration just begins and ends with XML declarations. However, there's other information that you should include in your file. For example, you should include the version of XML specification that you're adhering to. The version will almost always be 1.0 right now, although there is a version 1.1 that has some stricter requirements. You should include the encoding that your file is using. This will almost always be UTF-8 or perhaps ISO 8859-1. But as we'll see, there's some other common encodings. And then you should also declare whether your XML file is standalone and is thus just well-formed XML, or whether it's going to use a DTD that describes all of the contents of the file. And we'll talk more about DTDs in a second. I looked through over 2,000 XML files on one of my computers, and these are the different XML declaration heading lines that those files contain. As you can see, almost all of them use UTF-8 encoding. And there are also a variety of single quotes or double quotes that most files use. One or two files have ASCII encoding, and some files are not standalone. They include a DTD that describes the contents of the XML file. Well-formed XML has tag or element definitions that are encoded in greater than and less than signs. An opening tag is like that shown here, where there's a less than sign, the tag name, and then a greater than sign. A closing tag is similar, except it has a slash after the first less than sign and before the tag name. You can also have empty element declarations where you have the opening less than sign, the tag name, and then the slash and the closing greater than sign. And it's important to put a space before that slash so that this becomes a standalone empty element tag. The tags in an XML file can only contain certain characters. They're case sensitive, so your opening tag and your closing tag have to have the same words in the same case, and they can't contain any of several special characters. And it's also important that tags don't start with a hyphen, a period, or any of the digits. Tags really should start with a word that explains what the tag is about. Inside the tags we have the content, and there's very little restriction on the content, although it cannot contain a less than sign because that would indicate that it's a opening tag, or an ampersand sign because that's reserved for encoding symbols. If you want to encode some symbols, there are standard definitions. For example, if you would like to include a less than sign within your content of your XML file, you should include an ampersand, LT, and then a semicolon. Similarly, a greater than sign is an ampersand, GT, greater than, and then a semicolon. And so we have the standard definition where we have the ampersand, our abbreviation for what we'd like to include, and a semicolon that indicates that this is a special symbol. There are many other symbols that you can include in XML files, and you can find those online. Here's an example of well-formed XML. Every document has a root element. In this case I've called it root. You don't have to call it root. You can give it any name you want, as we'll see in just a second. And every open tag is closed. It's also important to see that there are no overlapping tags. Let's take a look at another XML file. Is this valid? It's not valid because we open node 1 and then we open node 2 and then we try and close node 1 while node 2 is still open. These tags are not appropriately nested for a tree-based structure. And so to make this valid XML, you have to close node 2 before you close node 1. In addition to tags and content, our XML file can also contain attributes. The attributes are housed within the tag, between the less than and greater than signs. They're key value pairs, where the key is separated from the value with an equal sign, and the value is wrapped in quotes. So for example, you can open a tag and then have attribute 1 associated with value 1, attribute 2 associated with value 2. In fact, a very common use of the empty tag that I've already introduced is to provide attributes. And so you can have an empty tag with one or more attributes associated just with that tag. So let's take a look at our student data that we've been using as an example in this class and see how we would describe that in XML. As a reminder, we have a very simple table with 3 students, each of which has an ID, a name, and a year. To make a well-formed XML, we would start with our XML definition and say that we're going to use XML version 1.0 and a UTF-8 encoding. We then have our root tags. In this case, our root tags are called students. Within students, we have person objects. And our person object is comprised of an ID, a name, and a year. At each level, we provide the data within the opening and closing tags. We describe the first student, the second student, and the third student in the same way. This is well-formed XML that describes our student data. This table also represents two problems with XML. The biggest criticism of XML is that it has a very large overhead. It requires a lot of additional text for each element in the field. Just taking a look at our XML file, we can see that we've got many lines of text and many additional characters simply to describe the students, their IDs, and the years that they're associated with. The other problem with XML is that there's no definition of what must be in each field, or whether each field is required, is optional, or what kind of data type it contains. So the document type definition was introduced to overcome the limitation of the contents of the file. A document type definition describes what must be in an XML file. We start with a document type declaration that says we're going to use a DTD to describe this particular XML file. Our DTD has this structure. It starts with our document type declaration, and this says that we're going to use a DTD. We then have the name of the root tag. In this case, it's HTML. This is a specific DTD that I'll come back and explain in just a minute. We can then say that we're going to have a public identifier. In this case, it's an identifier that describes XHTML. Or you can have a system identifier that's not necessarily available to the public, but is located somewhere available to the underlying system. And then you have a link to where that DTD can be found. So in this case, the actual document type definition is described at this URL here. The document type definition must be included in each XML file after that XML declaration line, which must come first in the file, and before the root tag, which of course is named in the document type declaration itself. So what does our DTD document actually contain? For each tag, we have an element control. We say that we're going to have an element, the name of the tag, and the kind of contents that that element can have. For example, we could have an element called person that contains an ID, a name, or a year object. Associated with ID, name, or year, we can provide suffixes that describe how many of each of those we're allowed to have. 0 or more, 1 or more, whether it's completely optional, or whether we allow multiple choices. In addition to the tags, we can also describe our attributes in our DTD. Attributes use the @list declaration. Here we have the element, which is the name of the tag that has the attribute, the key associated with the attribute, the type of the attribute. It's usually going to be CDATA, but it could be other things, and I'll explain CDATA when we get there. And we can also provide a default value. So let's take a look at our student data and describe that using a document type declaration. We take our XML file and we add a declaration that we're going to use a DTD. In this case, we have a private DTD that's only available to the system, and this is the name of the file where we can access that DTD. That's the only change that we have to make to our XML file to make it a valid XML file. However, we've now added a contract, and we've now said that this XML will adhere to the contract that we've agreed to. So we have to create a class.dtd that describes that contract. We start and say we're going to have element students, and students can be comprised of one or more person objects. A person object consists of an ID, a name, and an optional year. And then within the person object, we have to describe each ID, name, and year. And in this case, we're just going to say that they are parsed character data, PCDATA. Once we've agreed to the DTD, if we put anything in our XML file that's not in our document type definition, our XML file will not validate. Now, we still have an XML file, we'll still be able to exchange it with other people, but they won't be able to check if our XML file really adheres to what we say it is. So you have to be careful when you include a DTD in your XML file, because otherwise the XML police will come by and arrest you for not validating your XML. Not really, I just made that up. Okay, so let's take a look at the XML and the DTD. So here's our XML file in blue, and here's our DTD file in red. We have a declaration that we're going to have an XML file. We have a line that describes our DTD. You can include an optional comment that describes the XML file and perhaps the contents of the file. Why did you create it? Who created it? When did they create it? And so on. And then we have our opening root tag, our contents, and our closing root tag in the XML file. We have a standalone DTD file which begins with an XML declaration, and then we have our comment if we would like to describe our DTD file and our DTD definition. So we're going to have two files that contain our XML data and describe what that data is. So let's take a bit of a closer look at parsed character data and character data. By default, everything in an XML file is parsed. What that means is if we have some text that's wrapped in tags like this text here, we start by looking at the outer tags, in this case the body tags. And we first parse this block, and we identify that there are additional tags, the P tags, inside the block. And so next we parse out those and take a look at the text within that. And then we identify that there's some more tags inside that block. And so finally we parse out the text within those tags. This is PCDATA, parsed character data. Everything is parsed, all of the tags are identified. In contrast to PCDATA, we can have character data. Character data starts with this declaration, and what that means is that everything in the block is just considered characters. Nothing is parsed. None of the tags are parsed out. It's just character data that's returned to the XML parsing software. So character data is wrapped within this very specific encoding, which involves less than and greater than signs and square brackets. And this indicates that the block of text within these delimiters is character data that should not be parsed out. We can further limit our options with an XML file by using namespaces. Namespaces were introduced to try and overcome conflicts between different types of data. For example, we've seen in our student data that we have two different definitions of year. We might also have a different definition of ID depending on whether we're talking about the student, whether we're talking about the class, or whether we're talking about the professor. And so we'd like to be able to accurately say the ID that we're talking about is this particular ID, or the year that we're talking about is the number of years that the student has been in school, or is the years until they graduate, for example. The way that you introduce a namespace is by using the XMLNS attribute, as shown here. So one very specific type of XML is XHTML. XHTML must contain the XML declaration, and it has to include a document type definition. There are three types of document type declaration that can be included. There's the XHTML strict, as shown here, the XHTML transitional, and the XHTML frameset. In addition, the root element must be HTML, and it must reference the namespace at the URL shown here. And that namespace describes each of the tags, the attributes that could be associated with the tags, and the content of those tags. So here's an example XHTML document. We have our XML definition, we have our DTD, we have our opening and closing HTML tags, and then we have the contents of the HTML file. If we contain all of this, then our HTML file is actually XHTML. An alternative to the document type definition is called the XML schema. This gets a bit confusing because DTD's relaxing, XML schema, and anything that where you describe the contents of an XML file are called schemas with a lowercase s. The name XML schema was introduced for a specific schema, and so there's a subtle distinction between the schema with a lowercase s and the schema with an uppercase s. The XML schema is similar to the DTD that we've already seen. It describes what can and cannot be in an XML file, but it also allows typing of the data, as we'll see. So XML schema uses the XS namespace, and you can have structures and you can have data types. Some example structures are shown here: element, complex type, simple type. And the data types are standard data types that you would expect to be associated with data in a strictly typed language. For example, things like strings, integers, positive integers. And so you can not only describe exactly what's going to be within an XML tag, you can also say, I'm going to limit that tag to these particular data types. For example, for our student data, we could say that we're going to use the XML schema described at this URL, and we're going to have a type of name student. Within student, we're going to have an element whose name is name and is a type of string. We're also going to have an element called ID that's going to be an integer. And then we're going to have an element called year that's a type integer that may occur 0 or 1 times. It's optional. So this is similar to the question mark encoding that we saw in DTD. So we've talked about XML, the Extensible Markup Language, as a way to encode data in text documents. We talked about two types of XML documents, well-formed and valid. And we discussed that valid XML requires a schema to describe the contents of the file. Typical schemas include document type definition, an XML schema, and there's also another standard called relaxing that we haven't talked about. It's important to remember, if you have a well-formed XML document, then it can be easily parsed regardless of whether or not you describe it with a schema. The schema provides an additional layer that says these are the values that I'm going to have in the particular fields. That helps people write software to parse the XML file because it allows them to know what to expect. But a schema is not required for an XML file, for a well-formed XML file. It's just an option that allows you to more accurately and precisely share data with others.